Morning. We've got new seats. Make sure you keep. No. Morning. New seats. Make sure y'all find your new seat before you sit down, please. Thanks. That's not your seat.
No way.
I'll meet the cook right here.
Dude, I'm hoping the curve is gonna be like, I'm gonna look so bad.
I've talked to you.
No, not yet.
Yeah. Front and center.
Yeah, everyone said
That's why. No, that's why we had a great grade. The whole time.
10 minutes. Not
I didn't want to really put her
I saw it came out, but my advisory, I have it's like no cellular data. And so I was going to school Wi-Fi. I have all my songs, like all my light songs.
It's just crazy.
You sit right here. Right there.
Yeah. We learned it.
Don't know.
Get on some new shit.
So
it was like an hour and a half.
So Val?
I was totally like that, honestly. If I
I've been waiting all weekend to put that in.
Dude, I'm scared. Like, I'm just like, I'm checking it like every other day. Just checking it.
What did we say on Jacob?
It was a fee.
Can I say that? Oh my god.
No, it was so good.
No, you're really. You're 27 on the
What number? 26 now or oh, actually. Wait, actually,
You're not going to guess
I might delete her.
No, I'm not.
Oh, that's
I guess there won't be a charge bill here. Okay, for us to get started this morning, I need y'all to find the number 40 that you picked up after the test last class. We didn't have time to get started on it, so we will have to hustle just a little bit to catch up with my other classes. But you should have that in your binder, please. Okay, so moving into our fourth unit. I guess I should say, I do try to switch up our seating chart a little bit more often for calculus. Most of the time, it's just to kind of, keep things fresh. If you're sitting in the same place all year long, it gets kind of, too routine, I guess. And I tried my best to pair you up with people I think you might work well with. So if you think you work well, will work well with the person next to you, the best way for you to encourage me to keep you to do that is to make sure that you guys do your best and stay on task.
I don't think it's in the.
Yeah, you picked it up after the test last class.
You happen to have an extra? I don't think I did.
We did 4 before 3.
Okay, let's get started, please. So part of me trying to sit you with somebody that I think you will work well with is also knowing when to get ready for class. So that was good, but could have been better. Let me erase all this. This is the stuff that my other class did. Okay, so most of the rest of our derivative work is on something called function analysis, which just basically means if we give you a function, can you figure out what that function looks like? So you have done similar stuff with like quadratics. In Algebra 2, you do a whole unit on quadratics. You talk about finding zeros, you talk about finding vertex, you talk about finding whether it opens up or down, you talk about if there's a y-intercept. You piece all those things together, and then you can figure out what a quadratic looks like. Well, with calculus and derivatives, we can do that not just for quadratics, but for all kinds of stuff. So we will be looking today at the thing called the first derivative test. So we're actually going to look at a application of first derivative, and then specifically the thing that's called first derivative test. So within this, if we just use this as a quick example, the first thing that's going to come up in here that you have not heard of before is that there is a thing called critical numbers, actually, or critical points. And critical points, you will be asked to find those. So to find a critical point, it's when the first derivative is 0 or when the first derivative is undefined. So some of our step after step after step work will be finding the first derivative, setting it equal to 0 or undefined, and then solving, and that will find critical points. The reason critical points are so important is that critical points are the only place your graph might change directions. So notice it's changing directions right here, and at that instant it has a slope of 0. So anytime the graph might change direction, the first derivative has to be 0 or undefined. So to me this is kind of implied, but all of this that I'm highlighting in purple, what is true about all of that? Very good, it's going up, so we will call this increasing. And because it's increasing, isn't there something true about the slope of all of that? Positive. And in calculus, sometimes instead of saying slope, we say derivative. So when the first derivative is positive, it just means that the slope there is positive. And if the slope is positive, then it's increasing. So knowing where the first derivative is positive can get you increasing segments. Okay, what is true about all of this? Decreasing, which means the slope is, which means the first derivative is negative. Derivative means slope. So when the first derivative is negative, it means the slope is negative, and if the slope is negative, the graph is going down. It is decreasing. So one application of the first derivative is we can find increasing and decreasing segments. We can figure out when the graph's going up and when the graph's going down. Now, short of testing every point under the sun, we really only want to test around the critical points. So if these are the only places it might be changing directions, then we just need to test, like this would be a critical point. So if we can figure out it's increasing to the right and decreasing to the left, you can assume it's increasing always to the right and decreasing always to the left. Now the other thing, the whole first derivative test, the real purpose of this test is to find extrema, and specifically we're going to be looking at relative extrema. So do you remember what extrema means?
Isn't like the highest or lowest one?
Very good. So mins and maxes. Extrema means the mins and maxes. So this is a relative min. It's switching from decreasing to increasing. So extrema is the broader term that implies both mins and maxes. If we know when the graph is increasing and decreasing, and we can figure out when it's switching, if it goes from decreasing to increasing, we know we have a relative min. And if it was increasing and then decreasing, we would know we have a relative max. When you piece those things together, that's all the first derivative test does. So you already know how to do the hardest calculus part. It's just a matter of plugging all this stuff in to do something new. Okay, so if you have a minimum, like this example up here, you need to realize that the slope is switching from negative to positive. But in calculus, that means the first derivative is switching from negative to positive. When you do FRQs and it says find the relative mins, blah, 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 justify your answer, this is your justification. I know it's minimum there because first derivative is switching from decreasing to increasing. So to have a relative maximum, the graph needs to be going up and then down. The slope needs to switch from positive to negative, which means the first derivative needs to be switching from positive to negative. You okay? Okay, good. You're just looking at me. Okay, so these are what your questions are often going to look like. Here's a function. Use the first derivative test to find any relative extrema. So I want to find out if there's any relative mins or any relative maxes. Now, this is assuming I don't have a calculator, because if I had a calculator, I could just graph it and I could just eyeball it and probably find the answers pretty accurately. The other thing I don't want to do is I don't want to find the first derivative and then just plug in a million points to get an idea of when it's increasing and decreasing. So, but to use the first derivative test, obviously we do have to have the first derivative. So bring the power down, lower the power by 1, and don't forget chain rule. Now, to organize this information, we do this thing called a line chart. Now, line charts don't count as justification on an FRQ, but it's a good way to organize your thoughts, and you'll see why you will like this. Okay, but first, so here's the first derivative. So I could plug in a random number. Let's say if I plugged in 10 for x. If you don't write this on your paper, but if I plugged in 10 for x, this would be positive and this would be positive. A positive over a positive is positive, and when the first derivative is positive, what is the graph doing? It's increasing. The problem with this method is, how do I know it stops? It keeps increasing. What about at 11? What about 10.1? What about 9.8? I don't have enough time in my life to test everything. That's where these critical points come into play, because these are the only place it might change direction. So I want to know where could it be changing directions. So before I even worry about increasing, decreasing, I want to know, when does this equal 0 and when does a fraction equal 0? Fraction is 0 when the numerator is 0. So one thing on our sign chart over here, we're going to say at x equals 0, we have a critical number. There is a tiny difference. I don't think the AP test tests this, but there is a difference between critical number and critical point, by the way. Critical number is a number that makes the first derivative 0 or undefined, but if that's not actually a point on the graph, it can't be considered a point. So it couldn't be a critical point, but that doesn't really matter right now. Okay, when is a fraction undefined? Okay, so you would set the denominator equal to 0, divide both sides by 3, cube both sides, do that, and that's a problem. I added the 4 over and square rooted. Very good. You better remember plus or minus. When you square root both sides, you have to do plus or minus. So x equals 2 is a critical number, and x equals -2 is also a critical number. So there's 3 places that this graph might change direction. It doesn't mean it's changing direction at every one of those, but this is significantly better than just testing at the point 10 and testing at the point 9.9 and testing at the point 10.1. I know the 3 places that might change direction. So what we will do is we will test points around this. So I'm going to put 1 into the first derivative, and honestly I don't even care what the value is. I only care if it's positive or negative. So if I plug 1 into the numerator, I get something positive. If I plug 1 into the denominator, this is negative, that would be negative, and that's negative. A positive divided by a negative is negative. And when the first derivative is negative, that means that the slope is negative, and so during this time, I know my graph is going down. I know it's going down this entire time because, remember, critical numbers are the only place it might change direction. So, since it might be changing direction at 0, I need to test something between 0 and -2. So maybe I'll put in -1 into the derivative. that would make the numerator negative. It would make the denominator negative, and a negative divided by a negative is positive. And when the first derivative is positive, is it increasing or decreasing? Increasing. I should have said this earlier, but let me go back up here. We talked about increasing, decreasing, positive derivative, negative derivative. What about right here? What's the slope and the derivative here?
0.
Very good. So if you want to know when something's at rest, it's when the slope or first derivative is 0. Okay, so I can start to see the graph goes up till x equals 0, and then it goes down till x equals 2. But it might be changing direction at x equals 2, so I need to test something to the right of 2. You can plug in 10 million if you want to, but that's going to be pretty hard to do without a calculator. So plug in something easy, like maybe 3. If I plug in 3, the numerator's positive, the denominator's positive, a positive over a positive is positive, and so it's going up. And likewise, this is a critical number, so it could be changing directions here. So we need to test something like -3. Plugging in -3 would give me a negative over a positive, which is negative. And so yeah, this wasn't the quickest problem, but now I know this function, which I have no idea what this graph looks like, except now I know that it goes down till x equals -2, it goes up after that till 0, it goes down after that till 2, and then it goes up from 2 forever. So I know the direction when it's going up and down of the entire graph, just being able to do the first derivative in this first derivative test. So again, this is a good habit to do, but this doesn't count as any justification, but this helps you kind of organize your thoughts. Now I can see at x equals -2, what kind of extrema is that? It's a relative min, or local min. Is there any other minimums? Okay, at x equals 2, because it was decreasing and then increasing. So again, this isn't an exact graph or anything, but I can see it's dipping down and going back up. So x equals 2 is also a relative min. And then for the relative maxes, what does that look like?
0.
At 0, because it was going up and then it's going down. So honestly, this one question shows you a little bit of everything you need to know about the first derivative and the first derivative test. The first derivative can help you figure out when something is increasing and decreasing. Sometimes that's all the question asks for. And the first derivative test helps you find all of the relative maxes and mins. But if you know when it's increasing and decreasing, you can just kind of eyeball it. This is a max, that's a min, that's a min. And the only calculus you really have to be able to do is first derivative. So there's a lot going on there for this being the first example, but is there anything that I didn't hear that you want me to say again? Okay, then let's do question 2. And so then after that, it kind of dives into the practice. So I will have you guys try it after question 2. Okay, so question 2. If this was on your test, find the relative min and max of this function, and you did not have a calculator, because if you had a calculator, you could just graph it, and you could do the exact same thing you did in Algebra 2. You answered this type of question in Algebra 2, just your teacher provided a graph or gave you a calculator where you could graph it. So for us, we'd have to say, well, I know he has, it's a relative max if it switches from increasing to decreasing, and a relative min if it switches from decreasing to increasing. I can know when it's increasing and decreasing based on the first derivative. When the first derivative is positive, it's increasing. When the first derivative is negative, it's decreasing. But at the end of all that, I need to know something about the first derivative. So the only real calculus to this is taking the derivative. So this would have to be quotient rule. If you only learned the quotient rule to get you by for the last test, then you need to revisit it. And I don't want to test everything. I can plug in 1 for x and know if it's increasing or decreasing at 1. But then at the same time, I don't know if it's going to change anytime soon. So I really want to know when are the times it might change direction, aka the critical numbers, so I only have to test a few points around those. So like the last question, yeah, it was kind of a pain to test 1, 2, 3, 4 different values around the critical numbers, but it's infinitely better than just having to test everything. Now, I don't want to solve this for 0 or undefined yet, so personally, even though I don't have to, I would combine some like terms here. This is an x squared, up 1x squared. These would make minus 2x squared, so that would combine to make negative 1x squared. And then this makes 8x. So once it sinks in that critical numbers are so valuable because they're the only place that might change direction, you're going to realize you need to find critical numbers. So critical numbers can be when the first derivative equals what? Okay, and a fraction equals 0 when the numerator equals 0. And of course the solving is just going to vary, but this one could factor. Looks like x could be 0 or x could be 8. There's two numbers that make the first derivative 0. Is that the only way to get critical numbers? It is not. It is much less common, but it is still a thing you need to know. Also when the first derivative is undefined. So a fraction is undefined when the denominator is 0. You can square root both sides. Subtract 4, divide by negative 1. There are 3 critical numbers. There's 3 numbers that make the first derivative 0 or undefined. Now again, on your next test, one question is probably just going to be finding the critical numbers, because they ask that even on your AP exam. Okay, so now I know he might change direction at x equals 0, because that's a critical number. He might change direction at x equals 4, because that's a critical number. And it might change direction at x equals 8, because that's a critical number. I only want to test the places around the places it might change direction. So whatever it's doing here, whether it's increasing or decreasing, it's going to be doing it the whole time because it's never changing direction here. So I'm going to pick in an easy value like negative 1, and I'm going to throw that into the first derivative. So again, you don't have to come out with a number, but you've got to be careful enough to know if it's positive or negative. Plugging in negative 1 would give me a negative over a positive, which is negative. When the first derivative is negative, it means the slope is negative, so it's decreasing. So we just make a little line that makes it look like it's decreasing as a visual. He might still be decreasing after that, but we don't know. It's a critical number, so he might be changing directions. So we need to test something between 0 and 4. I don't know, like 1, something easy. If I plug in 1 into the first derivative, I get a positive over a positive. And when the first derivative is positive, it means the slope is positive, so it is increasing. Test between 4 and 8, like maybe 5. You get negative 25 plus 40 is positive. Why is the denominator always positive? Because it's squared. So if this is negative and this is positive, this is negative. when he is negative, it's decreasing, and test something to the right of 8. 8's a critical number, so there's a decent chance it changes direction, but not necessarily. You shouldn't assume from these first two examples that it always switches at critical numbers. So if I try throwing in 9 into the first derivative, I get negative 81 plus 72, which is negative over positive. So that should be, that's going to be negative, right? Does that sound right? Again, I'm doing that part pretty quickly, but again, the numbers don't matter, and you're going to practice. So this is why, I'm glad they did this. I didn't make up this question or these notes, but just because it's a critical number does not mean that it's a relative max or min. It could be decreasing before and decreasing after. A great example of that you should be familiar with is x cubed. X cubed only has one critical number at x equals 0. This is what x cubed looks like. Even though he has a derivative at 0 here, it goes from increasing to increasing. There's no relative maxes or mins. Critical numbers do not guarantee relative extrema. It's just that they are very likely. Okay, so if you want to find, yeah.
I was wondering if I left my water bottle in here.
I hadn't seen it.
That's unfortunate. Okay.
Okay, so some of the times there are questions where they just ask you to find the critical numbers. So you're only really doing this. Find the first derivative, find where the first derivative is 0 or undefined. Some questions are going to ask you to figure out when is it decreasing and increasing, and sometimes that's all it asks for. But if it's technically the first derivative test, the first derivative test is about finding these relative extrema. If it's going down and then up at x equals 0, we have a relative min. At x equals 4, we have a relative max. Yeah.
Sure that the derivative of 5 is a negative?
No.
So it would be negative 25, because that's plus 8 times 5, which is 40. Positive on the top, to be positive on the bottom, because it's negative 1 squared. So wouldn't it be a positive number?
You are correct. I need to be more careful there. Okay, then it's not x equals 4, that's the relative max, it's x equals 8. So if a question says use the first derivative test to find relative extrema, then it's this. So there's like 3 different question types going on here. Okay, anything that jumps out at you about question 2? Okay, then flip it over, read question 1, and try to answer it to the best of your ability. And then I will be behind you just a bit to go over it as well. But good for you to think about it first.
I don't have to pay for it.
You're just now telling me?
Yeah, I was following along in my amazing breath.
Okay, well, but now you got to do that too.
Well, I'll write it down.
Did anybody else not pick it up after the test and not tell me to start a class? Cam looked at me funny when I went over it. I know how to do this. Just did that in the book. It only did better. Now, if you get stuck, start question 2. But try to answer all parts of question 1 completely, all parts of it, to see if you really identify what is working for you and what takes a little more thought. Okay, and now I'm going to stop you. So, if you didn't finish, that's okay. You should have at least seen where you slowed down and didn't know what to do. So, this is just a different way to do kind of a line chart. It's the same thing I was doing, but they just put it in a table. But you might want to draw some arrows here. When the first derivative is positive, means the graph is increasing. The first derivative is negative, the graph is decreasing. So I don't know, maybe those arrows help you. They help me because I can see it was going up and then down. So there must be a relative max at x equals -2. Then it was going down and down. So what's happening at x equals 0? Nothing special. But then at 3, it goes down and then up. So there is a relative min at x equals 3. Okay, did y'all get those two? Okay, but it also said, I wanted to see if you caught this without me just saying it, justify your answers. So why is -2 a relative max?
Goes from negative to positive.
That is perfect. The first derivative switched from negative to positive at x equals -2, then it must be a relative max.
Wait, is it not? Positive to negative. Hold on, I'm confused.
Me too. Better? It was me. I put the signs wrong.
No, I think I said it wrong too.
Oh, okay. Then I'll blame you. Okay, and then somebody else tell me, why is x equals 3 a relative min?
The derivative goes from negative to positive.
So again, I know I said this on the other page. This is the simple, most efficient justification what you should be aiming for on your work, because this is the best way to do it for your FRQs. This is what they're looking for. So don't overcomplicate it. Okay, make corrections there if you need to. If you need to ask about question 1, now's your chance. Otherwise, try question 2 and see how it goes. Again, I'm not giving you any hints. I just want you to try it for a second. I'm not going to give you a ton of time, but I want to give you enough time that you can think about it at least. Okay, I'm gonna stop you pretty early on this one because I bet there's a lot of corrections that need to be made on this. This might be the first time this has ever happened to you. This is not the function. The directions say this is the derivative. That makes a big difference. This is not a relative max and these relative mins because you're not talking about f, you're talking about f prime. So right here, during this time, is f prime positive or negative during this? Because it's above the x-axis, right? Above the x-axis, these are positive values. So this guy is the positive here, and the first derivative is positive over here. Positive means above the x-axis. And then all of this, since this is a first derivative graph and it's below the x-axis, during all that time the first derivative is 0. Now, this is kind of hard for students at first, and that's okay, but we will look at a ton of first derivative graphs, especially the rest of this semester, so it gets a lot easier. But there's only 2 places where it switched from increasing to decreasing and decreasing to increasing. So at x equals -2, we're going from the derivative is positive to negative, which means that x equals -2, f is a relative, is that a min or a max? Max. If you're trying to make sense out of this in your head, the graph in your head, that's hard to do. You need to think about this is positive because it's above the x-axis, this is negative because it's below the x-axis. If the slope was positive and then the slope is negative, it's doing something like this, relative max. Okay, likewise over here at x equals +2, the first derivative goes from negative below the x-axis to positive above the x-axis, and anytime that is happening, you have a relative min. So now that I have made sure that you realize we're not talking about the graph of f, we're talking about the graph of his derivative, and you have to adjust your thinking just a little bit. Finish copying that one down, and then try question 3. Since it's got the same directions, it should be okay now. But again, I don't want to rush you guys too much, but remember we started a little bit behind the other class. So. Okay, question 3, I will start off with the answer, and then that way if you got the answer right, you can just keep on moving on a little bit quicker. But I would say at x equals -2.5, you should have said there is a relative or local, same thing, max, because the first derivative is going from positive. I know it's positive because it's above the x-axis, positive values, to negative below the x-axis. And then also at x equals 1, you should have said there is a relative min, because the slope was negative and then it switched to positive. So there's the answers and the justification. It did say justify. So, but one thing that's still useful about this that didn't matter, notice -1 was a critical number. The first derivative was 0. And at x equals 3, it's a critical number because the first derivative is 0. Not all critical numbers are relative maxes and mins. Only if it switches over here. If it goes from increasing to decreasing or decreasing to increasing. Decreasing to decreasing looks something like this. It goes down and then it goes down some more. Increasing to increasing looks like x cubed. Increases and then it increases some more. So be careful not to think every critical number is a relative extremum. Okay. Anything that jumps out at you about question 3? You guys got that okay? Okay. Move on to question 4. But notice on question 4, don't take the derivative of that. They already gave you the derivative. They are helping you here at the start. Of course, sometimes you have to find the derivative, but that one's already given you the derivative. Oh, just a side note too. I know you guys complain about my room being cold, and I did make sure they put up a work order to fix the heater. But I heard that the whole building has no heat this week, so they're working on fixing the heat for the building. So you might need to bring a blanket or extra hoodie for your other classes. Okay. I don't know if I gave you enough time for question 4, but again, we're just kind of figuring out like where you slow down, what's the first thing that doesn't jump out at you. So notice this first question, or question 4 doesn't say anything about the first derivative test, but it asks you to find relative maxes and mins, which is what the first derivative test does. So the first derivative test says find where it's increasing and decreasing. And if you know where it's increasing and decreasing, you know the relative maxes and mins. To know where it's increasing or decreasing, you should find the critical numbers, which is when the first derivative equals 0. So, because this is 0, if this times this equals 0, either this could equal 0. So, -4 is a critical number. And again, this line chart, even though it doesn't count as justification, it will help you organize all your stuff. When does e to the x equal 0? If x is 0, anything to the 0 power is 1.
It doesn't?
It does not. So you can either try to solve that algebraically, or if you know what the exponential graphs look like, you remember that, it never equals 0. There's several different ways, but there's only one critical number. So now let me ask you, how do I go about knowing if there's a max or a min or neither at this point? What'd you say, Olivia?
Like on either side.
Okay. So let's test a number to the right of -4, like, I don't know, 0. I could pick -3, but 0 is going to be easier. And something to the left of -4, like -5. Because this is the only place it might be changing directions. So whatever it's doing at 0, it's also doing at -1 and -2 and -3 and everything in between. So these are the only ones we have to check. So plug 0 into the derivative, you get 4 times 1, which is positive, so it must be increasing during that time. So is it safe to say that this is a relative min yet? No, because it might be increasing here as well. Plug in -5. If we plug in -5, we get -1 times 1 over e to the 5th. Is that positive or negative? That's negative, right? Which means it's decreasing. So now we can safely say our answer, there is a relative min. I can see it now because I did this line chart at x equals -4. So on a FRQ, that's often 1 point, and then another point, justify it. At -4, g goes from being negative, g prime goes from being a negative to positive. Answer and justification. Yeah.
In an FRQ, if you accidentally said f of x instead of g of x, would you not get that point?
I would give you the point, and I think College Board would probably give you the point, but I would try not to do that because I can't promise that they would. But okay, so this is one of the harder questions. I know we did harder ones on the front page, but that was me doing the whole thing for you. To find relative mins and max, you need to find when it's increasing and decreasing. So you've got to find critical numbers to know where it might be changing direction, which means you've got to figure out where the first derivative is 0 or undefined. So question 5 is the same thing. They already did the derivative for you. You need to figure out where it equals 0 and undefined, although it's never undefined if there's no x's in your denominator. So it looks like this one should have 2 critical numbers. But now that you've seen question 4, question 5 should feel a little bit easier. So let me give you a minute to try that. So I'm gonna. Okay, so I factored this, found two critical numbers, -1 and -4. So these are the only two places the graph might be changing direction. The fact that this is a quadratic means it can only be changing direction in one place anyway. So you can see I picked some values around the critical number to test. You are welcome to put -4 into the derivative, but you just figured out that it's 0 during that time. It's constant during those times, so that's kind of a waste. But if it might be changing directions at -4, I picked two numbers, one number to the left and to the right. So plugging in -5. Now, notice you can plug that in here. So if you can do -5 squared plus 5 times -5 plus 4 in your head, at least well enough to know if it's positive or negative, great. Truthfully though, I like to plug it into the factored form. If I plug in -5 here, it's negative. If I plug in -5 here, it's negative. A negative times a negative is positive, which means the graph's going up during that time. Positive slope, positive derivative, it's increasing. Then do the same thing with -2. If I plug in -2 here and here, I get a positive times a negative, which is negative, which means the graph is decreasing. And it might be changing directions at -1, so I'll try 0. If I plug in 0, I get positive times a positive, which is positive. And now it's pretty hard to mess up after that. This is the visual of where all my answers should come from. Looks like there's a relative max, relative or local, whatever you'd rather call it, at x equals -4. And if I needed to justify like this asked me to, it's because g prime is going from positive to negative at that time. And I can see a relative min at x equals -1. And if I need to justify it, it's because the derivative was negative before it and positive after it. Only thing that can really make this question well, I guess the solving can be a little harder, but the only thing that really can make this question harder is if they don't give you the derivative and you have to find the derivative. Okay, you guys okay with that? Questions? Okay. Then next up, this little section. Let's only just do one of these real quick because we did one like this earlier, and it says use a calculator. But I don't want you to have to get up and get a calculator. So if this said use a calculator to find the relative extrema, you might think, okay, I'm just going to graph this. What's that say? X to the third minus 6 cosine x squared plus 2. Okay, so if I graph this, you're going to be tempted to say, do you see any relative maxes or mins in here? And that's because you're thinking of it as the function. This isn't the function f, it's the derivative of f. So instead of thinking about relative maxes and mins, is there anywhere where the derivative, which is graphed, is changing from positive to negative or negative to positive? Okay, so right here, if you had to get that to 3 decimal places, that's why we did this calculator circuit the other day. You could do trace, find me a 0, the 0 somewhere between here and here. So at 1.587, when x is about 1.587, we have a relative, is that a relative max or min? I am in degree mode. Good catch.
Change the graph.
I was just testing you. Okay, that's a lot different. I wish I had noticed that. Okay, so now, if I asked you if there's any relative maxes or mins, you might quickly say yes. But again, be careful. This is not a function graph. If this was a function, here's a relative max, here's a relative min. But that's an Algebra 2 level question. That's probably not going to show up on calculus test. But right here, and right here, the derivative is switching from negative to positive or positive to negative. So we could, I'm just going to tell you the answer in just a second. But you'd have to do this 3 times. You'd have to have your calculator find this 0, so it's within 3 decimal places. 1.018. When x is about 1.018, is that a relative max or min? Min. Okay, how do you know that's a relative min? Okay, because we went from a negative slope to a positive slope, but of course don't say slope. Say derivative. Okay, and then you could do that for the other 2, but again, just for time purposes, I'm going to just tell you what the answers are to this one. There was one other time that there's a relative min. It was at negative 1.922 for the same reason. And then there's a relative max at about negative 1.250. So it's not harder, it's actually easier. Just need to be careful and realize you're not looking at the function, you're looking at its derivative. But it's basically showing you where the derivative is positive and negative, which means you know where it's increasing and decreasing. So I'll either excuse you from question 7 or 8, or I'll give you more time to go back and do those. But. Okay, and then let's all go to question 9 for just a second. Let me do one more example for you. This is now inched out to the last possibility, the last thing that I said that can make this harder. So, same thing, we're trying to use the first derivative test to find relative maxes and mins, and we should be able to justify our answer with calculus. Alright, so my first goal, my short-term goal here is to find the critical numbers. Critical numbers occur when the first derivative is 0 or undefined. So, unlike the last few questions, you actually have to find the derivative. Sometimes that can mean power rule, sometimes it could be product rule, it could be quotient rule, it could be trig identities, it could be e to the x, it could be natural log of x, all that stuff we've been looking at. You have to solve this to figure out everywhere it is equal to 0 or undefined. Then you know where the critical numbers are, which means you know where it might be changing direction. Then you can start testing points around it. Just make sure you're plugging it into the derivative and not to the function. The function's great if you want to know a y value. If you want to know the rate of change and whether it's positive or negative, you need to plug it into the slope. So if I plug in 0 here, this is negative, which means the graph is decreasing. Good chance it's changing direction here, so I will try a number like 3 into the derivative. This would give me something positive, and negative 3. It might be changing directions. Plug in negative 3, you also get something positive, and once you have this, should be telling you everything you need to know. Just a matter of putting it into words. there's a relative max at x equals -2 because the derivative is going from positive to negative. No more, no less. And there's a relative min at x equals +2 because the derivative is going from negative to positive. Answers and justification. And again, all of just extracting that out of this. Practice making this. Okay, go ahead and try question 10, please. Okay, if you didn't finish, let's see where you slowed down a bit. So again, first derivative test implies you need the first derivative. So I took the derivative, I had to use product rule. So that would be the first big mistake you could make, because if you didn't use product rule, everything after that is wrong. I know critical numbers are when the first derivative is 0 or undefined. This is never undefined because I don't have x's in the denominator. Like this is undefined when x is 0 because it gives division by 0. But he could equal 0. So I set it equal to 0, and then solving this algebra problem, again, this can vary in difficulty, but this one I took out of GCF, And then if this times this equals 0, either this could be 0, except there's no value of x that makes that true, or this could be 0, which is negative 1/5. So there's only one place the graph might change direction, at negative 1/5. So I would like to know if it's going up or down to the right of negative 1/5, and I would like to know if it's going up or down to the left of negative 1/5. So I pick a number to the right of negative 1/5, plug it into the derivative. I would get 1 plus 0, which is positive, and negative 1, this would be positive. Actually, maybe I should look at this. This would be positive, this would be negative. A positive times a negative is negative. So it's nice that you don't have to know the exact value, because plugging in negative 1 into this would be a weird number. I could do it, but I don't want to. But I really only need to know well enough to know if it's positive or negative. Now, unless I made a mistake, it's painfully obvious that this is a relative min, because I can see it. And I pretty much have the justification here too, if I'm paying attention, because the slope goes from negative to positive. G prime goes from negative to positive at that value. This is what they're hoping you get. Okay, anybody get that far with the time I gave you? Okay, where's the most common place you got stuck? You did the product rule? Yes? And the solving? You didn't think to factor out a GCF? Okay. Well, hopefully that gets easier for you then. Okay, we're going to make a slight adjustment to the agenda here, because, well, partly we lost a little bit of class and we were a little bit behind the other class, so we don't have to be completely caught up to them by today. So I do need these book pages back. You do not need to do any of assignment 41, but I would like you to finish assignment 40. So this handout that you have, I think you've got like, I don't know, like 6 or 7 questions. I will share the answers on the website. So it should just be practicing with what we talked about so that you feel a little bit better on it next class. So if I'm not going to change the agenda here, so you might want to write it down. 41 is not, you don't have to do anything from the book assignment, but I would like you to finish up 40 and check your answers online. You done?
Yeah, I did it this weekend because I was bored.
Oh, okay. Actually, if you want to staple it, I'll ask for it next class. So I don't want to take it from you. So you guys have 10 minutes. If you don't have a calculator at home, you might want to come grab a calculator for those 2 questions. You're welcome to work on that. Call me over, let me help you. I will also share our daily puzzle though. Okay, I know a few of you saw this if you were here on PSAT day, but most people didn't see it. Huh? Yes, please. Yeah, even the 2 calculator questions we skipped, I'd like you to do those also. Make a change. There's no more assignment homework.
Okay. Yes. I got to move the corner and save. Look at this.
Corner and safety.
Look at this. Whoa.
Putting you at safety, I can see putting you at corner.
Look. This is the varsity.
That makes sense.
I had to look Grove, we play safety a little bit. So like I'm playing nickel safety.
So who's the nickel now?
Grayson. We got Grayson and Will.
Wait, whose spot you taking?
Well, I'm still gonna start at nickel, but I'm just gonna play. I'm Kendrick's backup and Brody's backup. And if they start getting torched, I'm really good at cover.
Yeah, you ever play safety?
I play 15. We're thinking about going to college for track. Are you going to college for track? You should try and get the time league, because that it really helps you get it. We're like a really good
Are you really gonna get any more work done though?
Like track is
Staring at the wall.
Like I was on my phone. Like I couldn't just like that's what I told him.
Dude, no, he did. He did?
For like 10 minutes. He was like,
I think I almost
That was last time.
really?
Anyone else around?
Well, they're moving all the DBs are like playing both quarters. Like Kendrick's playing both quarters. And they're like going to play these spots. That's low-key smart. Because our seconds are so good. Our secondaries getting.
They say switch out. Try
I think that's really smart, bro. Imagine like me, Brody, Kendrick, and Matt.
Brody's been doing fine. At least pretty sure.
Bro, Charlie, Kenny gets torched. Zay gets torched.
Nothing to be mad about just like I get off the block, I see the pass over my head, I look back at the guy holding it.
Yeah, bro. And I'm just like, when I played the second play,
Dude, it makes me so
bro, I did my jump first down, like, damn, we gotta stop. And then wide open. Massive.
one DB, mostly coverage, and like two touchdowns. Yeah, 2 yards touchdowns.